Hey guys, we're going to look at how to find inverses of linear functions. And a lot of the time when we're talking about an inverse of a function, we want to make sure that we find functions that are, in this case, one-to-one. So really the only other type that we may not see, like it talks about, are horizontal lines, which if you do an inverse of a horizontal line, well, that one won't give us an inverse function. But most of the cases we're going to look at will give us that inverse function. And again, the idea is this. We talked about in our second unit for part A, how can you tell that 2x minus 4 is a one-to-one? Well, remember we talked about before, you can use the vertical line test and the horizontal line test. And if it only touches that line one time in each direction, then it's a one-to-one function. Now, for part B, they want us to go ahead and they want us to switch the x and y coordinates, and then we can graph the inverse. So in the case of the points that we have here, well, I see 2, 0, so I'm going to put 0, 2 in. I have 3, 2, so I'm going to put 2, 3 in. 4, 4, and 4, 4 would be the same. And then we got some other ones. We got 1, negative 2, so that'd be negative 2, 1. We also got 0, negative 4, so that'd be negative 4, 0. And then you can kind of draw in that inverse. So for part C, you might notice that it says right here, what could we say about this line, the diagonal line y equals x? Well, that inverse is actually a reflection. So the inverse is a reflection over that line. And they want us to find the equation of the inverse. We're going to do part D together. We're going to actually skip over part E. And if you want to find the inverse of a function algebraically, which is a big focus of this lesson, you want to go ahead and you want to start by writing. So I'm going to write this up here just so I got space. You want to write down the function you're starting with. And then what you want to do is you want to switch the x and the y. So you want to switch x and y, kind of like we talked about in part B, where it says here. So if you write it like this, x equals 2y minus 4, then your goal at that point is to get y by itself like you would to graph in algebra. So you'd add 4 on both sides. We'd end up with, in this case, x plus 4 equals 2y, and then you divide everything by 2. So this is the form right here for E. That would be y equals x plus 4 over 2. And for D, again, this is a 1 in front of that x. So for D, it'd be 1/2 x and then plus 2. So you would always want to take that equation. You'd want to plug it in, and you want to check and make sure the points match up, of course. Easy way to check yourself, especially on a quiz or test. But again, like we just talked about, to find an inverse, to graph an inverse, it's all about switching, like it says here, switching the x and the y coordinates. That's the main goal of this lesson, is giving us those different ways of switching and finding inverses of functions. Now we're going to look at a couple multiple choice questions. And again, this one's pretty straightforward. They want us to find the inverse. They give you y equals 5x minus 20. Now, again, you could, if you get stuck at any point, you know what your equation is. We know that the x and the y coordinates have to be switched. You could try to graph the 4 choices one at a time and make sure that the points are, in fact, switched in this case. But again, let's use the algebraic method. So we're going to do x equals 5y minus 20. So I'm just going to do that. I'm going to add 20 on each side. So I got x plus 20 equals 5y, and I'm going to divide everything by 5. Again, if I'm going a little fast for you right now, just go ahead and pause it, copy down or rewind it and go back. And so in this case, we'd have 1 over 5x and then 20 divided by 5. So again, I'm dividing the 1 by the 5. I'm dividing the 20 by the 5. So it looks like right here that 4 is going to be my answer. Okay. We really need to have that slope-intercept form that we've talked about before. You really need to have that for the inverse. We'll look at one now where that's not the case, where you don't have that slope-intercept. Now 3 is, again, pretty similar to 2, so we're going to skip over 3. And 4 is similar as well. Again, it's asking for the y-intercept. So if it's asking for that y-intercept, when you get that inverse, it's all about that b value. That's your y-intercept. In the case of point slope, when we're talking about point slope form, we do end up getting a bit of a shortcut. Again, this equation of a line formula is y minus y1, and then it's the slope, and then in the parentheses it's x minus x1. So really what we can do here is we can go ahead, and if you switch the x and the y coordinates, that means that the positive 6 is going to come here, and the negative 2 would go in the back. So that's going to get us rid of, well, 3 and 4 in that case. And then our slope, again, becomes, when you switch it, the slope flips. So like on the first example, we had 2 and 1/2. So because our slope is 4 in this one, that means that 1 is going to be our answer for this question. So you would see that this 6 and the negative 2, we know that point, the point that we're using for this is going to be 2, negative 6. That's our x1 and y1 value. So again, we switch those two, make it negative 6 and 2. And then if you plug it back in, you're going to end up with those two values here and here. And then that slope, again, the inverse slope is going to be the opposite of that. So remember, if you have any questions, please ask in class. And as you go through each one, make sure that you're completing the inverses by switching the x and y coordinates.